Alrighty, let's take a look at 5.5. These are the notes. Don't forget that besides the notes, you also need to have the practice done. But let's begin with the notes. So we have already learned two different types of equations for linear functions. Our first one was y equals mx plus b. And our other one was y minus y1 equals m times x minus x1, close parentheses. So these two are great formulas. We've learned them, we know how to use them, but now there's one more. One more that is actually pretty nice. It is easy to use and you can find it pretty quickly. So let's take a look. This kind is called standard form. It is represented by the equation ax plus by equals c, where a, b, and c are real numbers, a and b are both not 0. So basically, we have our formula right here, and we're going to plug in a number for a, plug in a number for b, plug in a number for c, and we're done. But first, we're not even going to look at how to create the formula. We're going to look at how to graph from it. Yes, you can take a second and you can rearrange the formula so that it looks like it's in slope-intercept form, but I think you'll find it's not too bad to graph. The best way to graph is to find the intercepts. So we know that the y-intercept is going to be on the y-axis right here. So that means that x has to be equal to 0. So you need to make a little note that x equals 0 for the y-intercept. And then on the other hand, for the x-intercept, you have y equal to 0. This means that you're going to get a point that is equal to, you're going to get a point that has a number here, comma, and then a 0. On the other hand, y-intercept is going to be 0, comma, and then some number. I will show you the easiest way to figure this out. So if I'm looking at my y-intercept here, I'm going to make another little arrow down there, y-intercept, I know that my x value must be 0. Therefore, I'm going to get 4 times 0 plus 5, y equals 20. So I just plugged, I know x is 0, so I can just plug it in. And I don't even plug it in all the time, because it just disappears. So you can scribble it out, or I cover it up with my finger and think about it. So all I have left is 5 times y equals 20. So I think 5 times what number gives me 20? I'm like, y equals 4, because 5 times 4 gives me 20. Therefore, I can go and I can take this number and plug it in directly up here. And I have 0, 4 for my y-intercept. Now, for my x-intercept, it's very similar, except for you're putting in your 0 for your y value this time. So, I have 4 times 0. Oops, sorry, backwards. 4x plus 5 times 0 equals 20. Now again, you don't even really have to plug it in. You can kind of just scribble it out or cover it up with your finger. Then you think 4 times x equals 20. What times 4 gives me 20? Oh, x is equal to 5. So now I have my number for my x value here for my x-intercept. It's 5. Now, all I have to do is go and graph these 2 points. So I'm going to graph my y-intercept at 0, 4. And then I'm going to graph my x-intercept at 5, 0. Right there. And last step is I just connect the 2 dots with the line. And I have a perfect graph of this equation in standard form. So now it is your turn. Take a shot at this next one, and I will reveal the answer to you in a minute. Alrighty, so we have your answer. So for the y-intercept, you should have plugged in 0 for x, and for the x-intercept, you plug in 0 for y. It's kind of flip-flopped. Y-intercept, you plug in 0 for x. X-intercept, you plug in 0 for y. You should have gotten that 0, negative 10 is the y-intercept, and the x-intercept is 14, 0. Then you drew those, plotted those 2 points on the graph, drew a line through them to get your graph. And it should have looked like the one on the bottom. Sorry, it didn't fit on the graph, but that's how it goes. Now let's look at the next example. So we need to figure out what happens when we have a situation where we don't have an x in our equation. What happens? So I shall give you a hint. If it is y equals something, a number, we'll put a box there, that means that y is always that number. That means that I can have the point, let's say, for example, y equals 2. So that means that I can have 0, 2, 5, 2, 7, 2, 22, 2, 252. But y is always going to equal 2. This means that I'm going to go up 2 for every single point. Doesn't matter what number I pick, it's always going to go up 2 on my graph. That means this is going to be a horizontal. And I ran out of room. But that works, you get the point, is horizontal. On the other hand, if an x equals some number, let's use the same example, 2, in this case, you're always going to go over 2. Your point could be 216, 222, 1000, 650, but it's always going to be 2. This means no matter what, it is going to be a vertical line. So it should be relatively easy to look at these and say, oh, is it a y equals something? That means it's going to be a horizontal. So let's take a look at example number 1. Y equals negative 3. Circle 1, we get, oh, that's a horizontal line. Now we have B. Y equals 5. Oh, look, that's going to be a horizontal line too. Now on the other hand, x equals 0. X equals, that means it's going to be vertical. Take a second, do the last 2, and I'll show you the correct answer in about 10 seconds. Alright, here we go. We have a horizontal and another vertical. This is something that if you wanted to plot and make a table, if you forgot, you could. You would just have to make a table. Let's take example y equals negative 3, our x and our y. We know that negative 3 is always going to be y. And then we could plug in whatever numbers we wanted here, plot them on the graph. You'd see, oh, this looks like it's going to be a vertical line. I mean a horizontal line, and you would know your answer to the question in the case that you forgot. Now, let's take a look at example number 3. Example number 3, we have to graph equations like this. So, we're thinking, okay, x, that means x is always negative 3.5. That means I could go to negative 3.50. Oops, if I went to negative, that would help. Negative 3.50, I could go to negative 3.54, negative 3.510, it doesn't matter. So I can automatically just draw a line down negative 3.5. Sorry, that's a little off, but you get the point. And it's going to be a vertical line. Take a second, do the same thing for B, and I'll show the answer in just about 2 shakes. Alrighty, so you should have a line all the way down here at negative 6. Straight, horizontal line for y equals negative 6. Okay, let's take a look at example number 4. We need to write the equation now. So remember, if we're looking at a vertical line is always going to be x equals something. So all I have to do is go look at my graph. What number is this at? 1, 2, 3, 4, 5. 5.5. So I say x equals 5.5. Take a second to B. I'll give you the answer in just a sec. Alrighty, so we know it is a horizontal, that means y equals, and we go up 3, so y equals 3 should be our correct answer. Well, let's take a look at the next one. We need to know how to write standard form from the other two forms. This simply takes a little bit of rearranging. Remember that our form is y equal, if I could get the right form, it would be ax plus by equals c. So we need to have a number next to x, number next to y, and that number could be 1, equals c. So if we're looking at a, the first thing we need to do is get rid of those parentheses. They're ugly, we don't like them, let's get rid of them. So we're going to distribute that 4 to both of these. We're going to be left with I plus 3 equals 4x minus 4. Now, x and y need to be on the same side. So I need to move that x to the other side. So I'm going to subtract 4x from both sides. This cancels out. I'm left with negative 4x plus y. Notice how I always put x first, just like the equation. Plus 3, that 3 didn't disappear, minus 4. Now the 3 is in the way, I gotta get rid of that too. So I'm simply going to subtract 3 from both sides, do the opposite of what's happening. Those cancel out. And I am left with negative 4x plus y equals negative 7. That is standard form. Now, the next one's a lot easier. We just have to move one thing. We have y equals 2x plus 5. I need the x and the y to be on the same side. So I'm simply going to subtract 2x from both sides, because that's the opposite that we're doing there. And you're left with negative 2x plus y equals 5. That is standard form. There's a number next to x, number next to y, and c. Now, careful with these. You might think there's no number next to y, but there really is. It's just 1. 1 likes to be invisible. Let's take a second and look at our last problem. Our last problem says, write an equation in standard form that represents the following word problem. Each notebook in a store costs $7. Each rubber stamp costs $2. You only want to spend $27. Let n represent the number of notebooks you buy. R represents the number of rubber stamps you buy. So we're kind of given a simple situation. We know that we're going to use standard form. But in the case that you wouldn't know whether or not what form to use, whenever you see that you have things that two different items that cost different amounts or have different rates attached to them, you're going to use standard form. So in this case, a notebook costs $7, a stamp costs $2. Two different things costing two different amounts, and then we have a third number. When you have that third number, that's going to be a total. You know you're going to use standard form. So remember that our standard form is ax plus by equals c. This case, it tells us to let n represent the number of notebooks. That means we can put n just about anywhere. So I know n is notebooks, and notebooks cost $7, so I put the 7 right next to the n. On the other hand, we want r to represent the number of rubber stamps. Stamps cost $2, so I'm going to put my 2 next to my r. Then I put a plus sign in between because that's how the standard form works, and they're both positive 7 and positive $2, and you only want to spend $27. This is your total, which is going to be C. So we just wrote a standard form of a word problem. Hopefully that made sense, but remember that next, the last thing you need to do is you need to go to Blackboard and you need to complete the 5.5 practice. You should be able to do all the problems on that sheet, and make sure you place it in your Google Drive when you finish.